Can someone please stop?
Hey, what are you looking at?
So the product rule is for when you've got y equals u of x times v of x. So if you've got a function where like two separate functions are being multiplied together, then dy dx equals the derivative of u times v plus u times the derivative of v. Sounds complicated. Basically, what it is, it's not at all. You're just doing, you find, because you've got function u, you've got function v in your original function. You find the derivative of u, you find the derivative of v, and you kind of cross multiply. So you're actually doing just the derivative of u times v plus the derivative of v times u. U being this function here, v being this function here. You just find the derivatives of both and kind of cross multiply them.
Is that all there is to it?
Pretty much. It's not that difficult, I promise. So for example, this one. So quite clearly we've got two separate functions in the two brackets that are being multiplied together. So we'll call the first one u and we'll call the second one v. Right? All we have to do is find the derivative of u and the derivative of v. Right, so derivative of u is what? Yep, derivative of v, 3x squared. So dy dx equals, okay, so we're doing derivative of u times by v. So we're doing these two times together. So we're doing 2x times by x cubed plus 8. And now we're doing these two times together. So 3x squared times by x squared plus 2. That is all there is to it. And then simplify if you want to. So if we want to simplify, we can expand our brackets out. So 2x times x cubed, 2x to the 4, 2x times 8, 16x, 3x squared times x squared, 3x to the 4, 3x squared times 2, 6x squared. Collect your like terms. You've got 2x to the 4 and 3x to the 4. So 5x to the 4 plus 6x squared plus 16x. That is the final answer. Pretty straightforward, right? No, that is it. Okay. Sometimes it gets a little trickier because because doing finding the derivative of u or finding the derivative of v might have to use something like the chain rule.
See, I don't mind hearing that, but the thing is, in a test I wouldn't know. Like, so it just go on.
Well, it just comes down to practice. Right. So this is our function. Now, quite clearly, there's two separate functions that are being multiplied together. So we're going to use the product rule. We're going to call the first one u. And we're going to call the second one v. Probably don't need those brackets in there. Okay, v is quite easy, so we can find the derivative of v. What is it?
3.
Good. Now, derivative of u is not going to be quite so simple because we've got a function to the power of 2, so we need to use the chain rule to find the derivative of that.
Oh my god.
So,
You
could expand it, but we'll do it anyway because if it's like to the power of 30, then you want to use the chain rule.
Oh yeah.
All right. Well, what do you want to just skip chain rule and we'll do straight into
No, let's do chain rule.
chain rule?
Yeah.
Okay. I would like to show you chain rule because it is a special case where usually we let u equal the function, but this is already called u, so we can't use u again.
Can we call it O?
Can we use
So
any letter we want?
you can. So on the sheet I called it a.
Yeah, that makes sense.
So I said let a equal x plus 2. But now don't get confused about the order in which you do things. So u equals a squared. Now, because we've already got it called u. So we need to find the derivative of this and the derivative of that. Right, so we're looking for dA dx.
Otherwise, we use U again.
We can't use u again because this one's already called u and it would get really confusing.
U was like, that was Y, it'd be Y.
Oh, it'd be Y because that's
Yeah, so now we're finding the derivative of the first one and the second one. So dA dx. What's dA dx?
1.
Yep. And this one is du dA. Yep, 2a. So then du dx equals 2a times 1, which is 2a. And a, of course, is x plus 2. Right, so that is the derivative of u.
I'll do some way. Okay.
Right, we haven't finished yet because we've got to now finish off our product rule. So, dy dx is derivative of u times v plus the derivative of v times u. So, derivative of u times by v. So, you've got that derivative times by...
Is there a reason you don't extend it?
You can, if you want to. That makes it easier for you.
Miss, why do we put
You'll have
that?
to do it eventually anyway. Sorry?
Why do we put x plus 2 back in?
Because a equals x plus 2. Right? It's the same as how we always substitute our u back in. But this time it's not u, it's a. Right? So plus derivative of v, which is 3, times by u, which is x plus 2 squared. So that was u times v plus v times u. So then you just expand out. So 2 times 3x squared plus 3x plus 6x, 9x plus 6 plus 3 times x squared plus 4x plus 4 equals 6x squared plus 18x plus 12, no, just 12, plus 3x squared plus 12x plus 12. Right. 6x squared and 3x squared, 9x squared, 18x and 12x, well, not equals, sorry, 30x, 12 and 12, 24. That's the final answer.
What's the answer?
Yay!
9x squared plus 30x plus 24. So that is the derivative of that one there. Does everyone follow that?
Got
Yeah.
it.